So everyone's very welcome to our webinar today, Accelerating Electrical Harness Design. We're thankful we have an extra day in February to deliver this to you, but thanks for taking the time out of your day to attend our webinar. And it's nice to see some familiar names, some new attendees also. We look forward to sharing this presentation with you. So this webinar has been brought to you by IC Blue. IC Blue is a Siemens expert partner in the UK and Ireland for the electrical and also electronic design solutions from Siemens. And the goal of today's webinar really is to just give you an insight into how Siemens provides the best intuitive, data-driven and also easy to use solutions in the space that obviously you have an interest in. And especially as it comes to accelerating electrical harness design, we hope that you're going to get some benefit from today's presentation. Just a couple of things. The recording of this session is actually in progress currently. And the recording will be made available to any who want to have a copy of that afterwards. Please feel free to use the questions. There's a facility for raising questions during the webinar. So please use that. And as we have time at the end, we'll address some of those questions. If we don't have time to address all of them, we'll certainly follow up after the webinar and provide you with answers to any of the questions that were raised. Probably the first question that most people ask, is the slide deck available to me? Well, yes, the slide deck can be available to you on request. So my details are at the end of the presentation. Note those down and send me an email and we can make that available to you. So by way of introduction, we have with us today Nuri Zagat from Siemens. Nuri is the Capital Portfolio Development Executive. And thank Nuri for his time out today and delivering this presentation to us. And at this stage, maybe I can hand it over to Nuri, and if you want to kick off the presentation or if you've got anything introductory to say.
Thank you, Brian. Good afternoon, everybody. So as Brian said, I work for Siemens, and my responsibility is the business development of capital. I support our partners across Europe, our expert partners like IC Blue, and also some of our aerospace and defense customers and automotive tier 1 customers. Prior to this role, I was actually one of the R&D product owners, so I have a long background within Siemens on the capital portfolio. So the title of this presentation or webinar is Accelerating Electrical Harness Design, and the agenda that we've got out here is really starting off by looking at what is Siemens Accelerator at a very high level, creating an analogy between Siemens Accelerator and the automotive industry, looking at the capital portfolio, so the capital tool suite from Siemens, what is it, and what kind of flows are available, and then I'm going to hand over to Brian, who's going to do a deeper dive into the platform interactive flow for capital, going through various different elements of the flow, and then we end and summarize, and we'll take some next steps and questions. So as I said, I look after a lot of automotive, aerospace and complex machinery companies across Europe, and one of the customers I look after is ASML. They make lithography machines for the silicon industry. There's a lot of cables and a lot of cable harnesses inside these machines, and one of the thoughts that they have is their machines are getting so complex and so big that they can't simply add more engineers to their projects. They need to transform the way in which they were doing their design flows to be able to handle this massive increase in complexity that they have across their platforms. And this is a statement that I don't think just applies to ASML and complex machines. I think it's actually a statement that applies to many different industries. Automotive, with the big increase in electronic content and autonomous features and electric drivetrains, and all these elements or trends are driving up complexity, affecting all industries. So now I'm going to make the analogy to what Siemens Accelerator is and try and analyze or compare that to the F1 industry. So this is a short video showing a pit stop in the 1990s, McLaren F1 team. Pay attention to the lollipop man once he holds holding the lollipop when all the wheels are down. So I start it, all the wheels are being changed, there's lots of people doing it, and he pulls away when everything is checked and everybody's finished their tasks. So I think that's quite impressive. I think 7-second pit stop is a pretty impressive time. surely we are asking ourselves, that's fantastic. We hit the nail on the head. And then I think about my other customers. I look at ASML, who year on year are creating more advanced, more complex machines. You guys are creating more and more complex platforms across your industries. Is it right to just say, is it good enough? And the answer is no. There's always an opportunity to improve. There's always an opportunity to drive drive ahead of the competition and gain that competitive advantage. So if we look at a modern day pit stop and how that differs from the 1990s, well, it's quite interesting because there's a lot more digital continuity in the way in which everything's working between the sensors, the switches, the actuators, the guns. There is that digital thread that everything is connected. The whole process is a connected process. There's a lot of automation, in the process. The shuttling of the wheel guns. That's eliminating manual tasks, so you don't have to check. There's one less thing to check for the people on the team. And even the jack drops down automatically once all the wheels are on and torqued. So again, you're eliminating another manual check that the guy, the lollipop, used to have to do. He had to check around to make sure everything was actually done and ready. And the traffic light release system, it's reducing potential for errors. It's supporting multitasking and allowing each of the technicians to focus on their individual tasks. So by connecting that end-to-end process, a modern day pit stop is much faster. So there's a greater reduction in errors, but there's a smooth transition between all the different processes, and all that automation has removed manual tasks and ultimately increased the overall speed. And you'll see a little video later to see what that looks like in real terms, but that's a significant saving. And that's the vision behind Siemens and Accelerator. What we have within Siemens is a multi-portfolio of tools that are created together to be part of what we call Siemens Accelerator. And the key element of Siemens Accelerator is to digitally connect all the tools and processes to allow smooth transition and handoff between the different design domains, powerful automation tasks, get rid of a lot of manual steps, and that's enabling our customers to take the benefits of increased development or increased development time, better designs, more time to actually invest in in engineering rather than doing mundane tasks, and that ultimately is giving better designs right first time. So that's the goal of Siemens Accelerator. And within Siemens Accelerator, obviously today's focus is on Capital, which is the product platform that I support. But Siemens Accelerator includes mechanical, application lifecycle management, product lifecycle management, simulation tools. So there's a whole vast array of products that all fall under the Accelerator portfolio. Capital is the one for EE, and that stands for Electrical and Electronic Systems Design. So you might hear me use that acronym later. So that's a very quick introduction to what Accelerator is, Siemens Accelerator. But if I just look at what is Capital, I think there's a lot of people here. I saw the invite list earlier. There's people who probably are familiar with Capital to some degree, but did you know Capital is actually so many different products? There's 200 different part numbers in the price book for Siemens for Capital, and it covers a huge number of current roles within an organization, from systems architecture to software, electrical, and even the integration. So there's a lot of capabilities within Capital. And if we look down one layer deeper, we start off with electrical architecture. So on the left-hand side of the picture, we're able to, Capital can take system models from other system modeling tools, from Teamcenter or IBM Rhapsody as an example. We're able to absorb those functional models, and as an architectural tool, we can assign functions to ECUs in a platform and look at the efficacy of the overall platform, understand, putting these functions together. I'm creating this software requirement. I'm creating this additional network requirement. By the way in which I distribute my functions across the different ECUs and equipment across platform, I'm impacting potential wiring, network, software development. And so the system architecture tools that we have here are really for early stages of an architecture of a platform where those decisions you make at the very beginning greatly impact the longevity of a platform. And then on the top row, under software, we've got tools for developing the software, actually writing the code that would be part of the overall platform, the network design, understanding the timing analysis, how signals are packed into messages, and all the different networks you have on your vehicles or your platforms. Are those messages getting to their intended destinations in the time that you'd expect them to get there? And so, really, this is all interconnected in that digital thread I described, with the pit stop analogy. There is a digital thread here from the architecture all the way through to software, and also down into the connectivity, for the creation of the wiring schematics, the harnesses, and final technical publications. So altogether, Capital has quite a vast array of products. Today's focus is really going to look at the connectivity, looking at connectivity and harness, and looking at how to accelerate wire harness design process with Capital. So some of you may be familiar with a product that used to be called VSys, which is now Capital Essentials. Capital Essentials is a subset of this overall capability. It's actually graphically about that big in terms of the overall. So it's got a basic schematic and harness design capability, but really that's all part of the overall suite. And some of our customers have started off with VSys, Capital Essentials, and as they've wanted to do more architectural work or network design, they've expanded their use of Capital, and they've gone into a full Capital flow. So if we go back to that first red box, the connectivity, how can Capital help in the design of electrical wire harnesses? And the answer is it depends on what you're trying to do and the kinds of problems you're trying to solve, because there's multiple flows available that customers can follow when it comes to creating electrical systems. We have our interactive, our traditional flow, which is number one at the top. This is effectively a schematic and harness integrated with mechanical, and just that connected tools replacing what would have been AutoCAD or dumb drawings. You're already able to improve the quality and consistency of your data, reduce the number of changes. But the flow can also be enhanced further by step number two. This is used by automotive and complex machinery and aerospace customers. By adding in a topology, you can actually visualize the overall platform, and we'll look at this later, but the topology tool is really providing a platform view of the overall electrical and electronic systems and the wiring harnesses within it. We have a couple of flows. These are part of our generative portfolio, which is more rules-based automation. So instead of creating wiring designs manually, they're actually a byproduct of an automation process, fully controlled wire synthesis based on the architecture and rules and constraints. But as I said, today's focus, I'm trying to capture the masses. What's the big step up for customers with the platform interactive flow of Capital? So I'll do a quick walk through what this means, and then Brian will actually do a deeper dive. So it starts off with a schematic tool, and the product that we have here is Capital Logic Designer. Back in the day, I was the product architect for this product. This is the schematic tool able to create functional schematics as well as physical wiring schematics. And so it's equipment, it's components, it's connectors, it's wires, it's splices, it's multi-core cables. Underpinning Capital Logic Designer is a component library where we have all our reusable assets, our devices, our components with the correct mating connectors, all the relationships that you'd expect to drive that automation is reusable and is part of our component library tool. We'll also talk about, well, when we have all this connectivity, these multi-pages of schematics, how do we visualize it and understand how those wires are routed together within a platform? So for this, we'll use Capital Wiring Integrator, which is our topology tool, and this is going to allow us to really control how wires are routed. Power and data can be kept separate. There's sometimes choices to be made with regards to the routing of those wires, and that's the advantage of a our topology abstraction. Now, of course, in the real world, we need to make sure that we've got the correct lengths, that we have all the correct positions of the clips and grommets and the geometry of the harness. So we do that by working with 3D. One example is working with NX. It could be solid, solid edge, it could be solid works, it could be, we're quite agnostic when it comes to the MCAD tool that's used. But in here, we'll actually do some data exchange and talk through the process of working with 3D. Taking that, to manufacture the harness, we'll take that 3D geometry, we'll generate all the manufacturing documentation, and if necessary, the form boards in Capital, all digitally connected, no silos here, there's no swivel chair re-entry of data. This is all part of a connected flow. And that's a connected flow that's also controlled through our PLM offering. So Teamcenter can control the workflow, it can control the actual the single source of truth for all that data that's visible below. What I'm not going to show in the presentation today, there's two little grey boxes on the left. So I talked about Capital Component Manager, which is the library tool. There's also an ICD tool, an interface control definition tool called Capital Device Modeler, which is able to greatly automate the process of managing those and consuming those ICDs within the platform design. So now I'm going to hand over to Brian.
Excellent. Thank you, Nuri. I really appreciate that. That's a good overview of the Capital flows. And again, if you want to raise some questions, please put them in the question box and we'll get to those afterwards. But since today our focus really is on the Capital platform interactive flow, we just want to delve into a little bit more detail. So maybe we can have the next slide on that, Yuri. Thanks. So the areas we're going to look at today, we're going to start here in the first section of the electrical schematic design. And so logically, drawing our schematic, Capital Logic, it's a powerful, it's a graphical and design management environment where you can authorize your drawings, both logical connectivity, but then you can turn those logical connectivity drawings into wiring designs. And so what we'll cover here as you can see on this slide, just some of the things we'll touch on today, explain what does that mean, turning nets into wires, how can we create that new logical schematic design, how can we place devices, or how does it work when devices are placed on the fly, or how are devices even connected, some automation around that. And then we'll touch on some of these other areas as well of creating multi-cores, adding shields, and those aspects as well. So just on that idea of nets to wires, in this interactive flow, we're converting nets to wires. It enables you to convert system design into a wiring design, as we mentioned. And so what you're looking at here is being able to do that on a single design, or you can convert all the nets in a build list specifically. We're looking at devices being able to be placed on the fly easily from our library within the tool, devices and components, how those pins can also be placed on the fly. And also, once the function of these designs is nearing its completion, as you can see towards the end of this video, the schematic can then be converted into a wiring design using the nets to wires function. And so the library parts have been associated. Just at the end of that, you saw the library parts have already been associated. It runs quite quick, that video. But that means then that each of those, the line replacement units on that design can be associated automatically. And because these library parts, again, as Nuri mentioned, within the library have the correct associations, it allows to use automation to cut down the time to be able to assign those, making sure they're assigned correctly, but also being able to select things like the harness connectors with just a click of a button. So that's just a very quick overview of that. So maybe we can have our next slide. Yeah. So what does this result in then, looking at these things and the way Capital Logic can be used? Well, it results in a flexible, it's intuitive, it's data driven, and it's an easy to use schematic tool. For those possibly already on the call that are using Capital Essentials, it's a familiar user interface and user experience. It's just far more functionality and capability within this particular product. So that's really flexible, intuitive schematic design is what we see here. Maybe we can have our next slide. Yeah, as you can see, we've skipped point number 2, as Yuri mentioned, but we're not going to speak specifically on the library today. I think possibly a webinar in that in itself, describing the functionalities and the associations that can be created there. But the tool does come with a fully equipped component management tool for creating symbols, components, wires, and then also then predefining all those associations, as Nuri mentioned earlier. And that just allows then for that automated way of being able to select those parts, having it right first time in your library, having the confidence to be able to place that device and knowing that the connector that's associated with that is the correct one, or maybe knowing that the terminals within the cavity of a connector are the correct ones that have been selected, or even down to knowing that the wire is correct for the cavity that that's going into. So we look at here the topological design, and we're looking at capital wiring integration or integrator. And what we're looking at here is just some of the things that we're going to cover, some of the content. This particular tool allows you to design and also manage wiring topology abstractions. And it gives a really high view, an integrated view of the platform that you're working on and all the wiring content that's in that wiring platform. So maybe it's time to ask a question, well, how do I get that view at the moment? Do I have a view of that at the moment? Is that something that I have, or am I using manual processes, maybe some workarounds to fully understand the topology of my design? So yeah, so this slide here, we're looking at a familiar scenario. You're at this stage, you've created your schematic design. The connectivity has been done. Maybe this is a base block of circuitry that you use on a regular basis. But some questions come up at this stage. We're looking at, well, how do we work out how the bundle and the wires in the schematic, how do they go together in the harness? How do I visualize that? How do I work that out at the moment? And maybe if you imagine a complex vehicle, lots of harnesses, lots of things to route, how do you determine the best paths for that solution? How do you come up with the best solution for that? I think maybe a lot of you probably don't have to imagine that. You're probably already involved in doing that, and these are real problems that you're facing and questions that you're facing. But maybe you have next slide as well. Thanks, Nuri. And just before we touch on that, sorry, I've just missed one. Just even when we can work out those things, and if we can work them out in a way, how can we optimize very quickly? So how could we go and look at that and optimize quickly, maybe for weight, for a number of split connectors across the harnesses, or maybe even cost? Maybe we're tracking that. They're all very time-consuming exercises and things that could be addressed with this particular tool. And so as this slide shows, this is really where the capital wiring integrator comes in. It brings a highly integrated view of the platform that you're working on, with all its wiring content into you. So what are the benefits? Well, the benefits are going to be you use it to distribute the components throughout the platform. You can route the wiring, the from-tos of these components through the harness. You can get good visibility of that. You can use it to establish, again, those split connectors and the locations and even maybe the sizes of what they need to be. And really what it's doing is buying you back some time to innovate, doing what you do best as engineers, and to be able to innovate and optimize the layout of that wiring harness and get the most out of it. And maybe it is you're evaluating different scenarios. You might just be able to spend some extra time tracking some KPIs. Maybe it's something that of interest specifically for your project. It just gives you that little bit more time to be able to find that optimize that layout. So we're going to run through a video, and again, we'll just talk you through this. It runs at a bit of speed, but here we're using Capital Integrator to develop a topological view of the wiring, how it's bundled and routed through the product. And so first of all, we're just going to associate the wiring diagram of interest from Capital Logic to the topology plane that we have here that you can see. It's at this stage then that once that's done, that association is made, components can be cross-referenced between the two abstractions here. And what we're looking at then is we have maybe a scenario where we have two wires that haven't been routed through the topology, so we need to be able to figure out why is that, so we can use, again, the cross-probing to be able to investigate why. And the tool offers here two different possible ways to route the wires through the topology, again, through some automation. So it lets us make the decision. But in either case, an inline connector has to be added, depending on whichever solution we choose, but that's not actually in the design at the moment. So we make the best choice that we can, and considering maybe rules that we might have of keeping certain nets away from each other, certain wires away from each other. And those missing inline connectors, then they're automatically populated or added to the design. And we can even manage down to the level of the pinout of that to make best use of those connectors. So all of that information can then be used as well to prepare for the harness design. All of that information can be pushed back into Capital Logic that can then be forwarded to Capital Harness for later on for manufacturing drawings. So we're looking at this correct slide. What we're looking at here then is what's the benefit? What do we see? Well, using Capital Wiring Integrator, it allows you to fully optimize for a full platform wiring. You get a topological view of your whole platform, and allows you time, again, we say, to innovate and to find the best solution, to find it quickly, and to do it within an easy to use environment that can be relied on. So maybe we can have our next slide. So here we start then going on to the next section of schematic to 3D data exchange. And what we're looking at here is passing the wire information to the 3D routed harness in your MCAD tool. Again, not necessarily has to be NX, but this is the example that's used in this slide deck. But why might that be necessary? You might think, why would I want to do that? Well, it increases visibility across disciplines. They could be quite separate, and they are separate quite a lot of the times, traditionally siloed, as was mentioned. It also liberates your designers from the manual, maybe the error-prone work that's done to try and compare these different disciplines and different products that are being produced from the different tools. But it can also boost productivity and the design quality of what you're producing, and enables you to quickly create maybe better products where maybe the impact of that electrical and mechanical decisions, they're made quicker and they're made maybe even better. So what are we going to show you here, as this slide mentions, we're going to show you some of these points by way of a video. So again, if we can play that. So we're starting in the NX side of things. We have a view of the wiring, the 3D harness that's been created. Some of the parts and the connectors and supports and things like that have already been placed in the design. You can see that with the spline paths routed between them. So there is some definitions already created. And now what we can do is switch to a connected mode between NX and Capital Logic. So we're directly connecting the two tools together. And then we can filter on which harness we're interested in to push over. In this case, it's the rear cockpit harness. And so we bridge out that information, we export it from Capital Logic. And because the tools are in this connected mode, NX receives that data and it's passed over. There's some auto assignments of components that's been done there, as you can see. That will map between Logic and NX. And because, again, it's a live cross-programming between the two programs, each object can be selected on either side, and anything not mapped can actually be manually assigned here. There's an example of the splice that's been manually assigned. But all the wires can then be auto-routed along that the spline paths in the mechanical tool, and they can be calculated as they route along those paths for the correct wire lengths. And at the moment, back in, just again, it runs so quick, it's hard to keep up. Just to go back to the capital side of things, the lengths are not there, or the correct lengths are coming from topology at the moment, but we want the actual lengths that are coming from the 3D harness. So that's why we would like to have that information pushed back, because capability within Capital Logic allows you to do some simulation. You may want to do some volt drop analysis, now knowing the correct length of that wire that's been passed by. So again, thanks for that video. Let's switch to the next slide. And so again, what's the benefit? What do we see? Well, we saw how we could connect the two tools together, how we could import the data, how we could auto-assign components, the mapping between the two tools. We could cross-highlight where there's a connection between NX and Capital. That is unique to NX and Capital. And we can also then auto-route the wiring and then bridge out the wire links back to Capital. So using that schematic to 3D data exchange allows you to break down those silos. It allows you to maybe improve the engineering discipline and remove the error-prone and manual steps that may be there in your kind of flow. So maybe we can jump on to the next one, which is point number 5, is harness flattening and harness engineering. So again, you might ask, well, what is it? Why do we want to do it? Well, we can import an existing 3D harness topology that's already been drawn in the mechanical world, and we can effectively and efficiently produce a high quality drawing of the harness from that. And again, maybe why? Again, increases visibility across your disciplines. It liberates, again, your designers from the manual tasks, maybe error-prone tasks. It boosts the productivity and the design quality. and maybe enables you to create some better products, again, where this is an important factor, the communication between mechanical and electrical. So what will we cover in there? As you can see on this particular slide, we'll look at that connection from NX to Capital Harness in this case, how we can export and flatten the design from the MCAD tool into Capital, and also then how we can start that manufacturing prep on that side, how we can cross-highlight between, again, NX and Capital Harness in this case, and how we can synchronize that wiring data. Again, why we'd want to do it, optimize the splice positions is towards the end of the video, so watch out for that. But maybe we can play that video and we can see how this is illustrated. So again, we start creating a new harness design. The connection to Capital is done in the same way as it was with Capital Logic. And then we can use the harness view to see the resulting flattened view before we import it into Capital. So it's bridged out of the mechanical tool. We can get a view of what that looks like, and then it appears on our drawing. We can reposition some of the components just to make sure they fit on our drawing template. And then we can use Capital to optimize the position of the splices, in this case, is what's illustrated. And then we can import that information back to the MCAD. So here we can drive from the harness tool the positions of those back to MCAD to optimize them. Then what we can also do is we can use automation within Capital to automatically match all of the terminal part numbers with the connectors and the wire gauges that are used. Again, we mentioned that's the core of the library side of things. And also we can use Capital to generate that full BOM of all of the materials, as it mentions there, all of the materials, raw materials that go into building the harness. We can track all of that within our Capital harness tool. It can also connect, as it mentions here, towards the end to Teamcenter. And here we have an active workspace that appears within the design tool, within Capital, if any are familiar with Teamcenter. And directly be able to search maybe within that workspace, within that tool, for objects that are related to this project. Again, we find the project within Teamcenter by just selecting it and doing a search. Again, all within Capital we're running here. And then what we can do is we can have a look to see was there any files associated with that. We can see in this illustration there was no files associated with this design. But we go back to Capital, we generate or we publish our design to Teamcenter, and we come back in, and when we look at the attachments, we see that all of those files have been generated, those additional files have been generated for that project, and again they're there for our use. And as Nuri will discuss a little bit more on the Teamcenter side, how that can manage and maybe in more detail the products. So again, if we push to the next slide, what's the benefit of it? What have we looked at? Flattening the harness and harness engineering. Well, we can automate the processes, we can increase the productivity, and we can certainly increase the accuracy of the information that's been passed between both. And again, this idea of automation saving time, giving you back that time to be able to innovate what you do best. So Nuri, maybe I can hand back to you at this stage, and you can take us through the Teamcenter section.
Thank you, Brian. So, I mean, the key thing here is product design these days is not just one discipline. It's not just electrical or mechanical or software. It's a multi-domain, multi-disciplined activity. And so all of this can be orchestrated through PLM. And in our case, it's Teamcenter. And Teamcenter is not only managing the design data, but it's also managing the workflow, the process, and even the library parts. And so there's a whole approval process here driven by Teamcenter. So Capital itself is orchestrating the EE systems, the electrical and electronic systems, in the context of the whole product, and the whole product is where Teamcenter is playing its part. So within Capital, we design electrical systems. We can then publish a bill of materials. Teamcenter has the multi-domain bill of materials, the M-BOM as well as the E-BOM. Teamcenter is managing the life cycle of those designs and the configurations, but Capital is creating it. And so really that's the whole goal here, is that this is a PLM-driven workflow. How are those two different products aligned? I mean, it's all part of Siemens Accelerator. You can see that Teamcenter sits within Capital. It's a seamless part of the Capital experience. But Teamcenter, as I said, is the master of the design, library, the bill of materials, and the life cycle. It's there to govern the release process and the change management process, but it's doing this for all the different domains that are involved in the product design. Looking at Capital specifically, Capital is following that release process. It depends how tightly you want to couple the two systems, but effectively it's the master of the authoring of the electrical systems design. So that's really the goal that we have within Capital, and why there are two tools here. So completely integrated, and I think if we look at Teamcenter as an example, I will create design data in Capital. I will have my engineering data, my harness bill of materials. I can publish that into Teamcenter. So Teamcenter holds the complete bill of materials for all the different products and sub-assemblies of the platform, and that workflow, that design workflow, is something that is orchestrated by Teamcenter, and you'll see that in the next video here. So if I just go to the next video, I can press play and pause. So hopefully this works out okay. So I'm inside Capital, and I am now just going to publish this harness design into Teamcenter, including the bill of materials. Do that as a single action. Teamcenter is going to get a copy of all that design data and all the related artifacts, like the bill of materials. It can also have other reports stored in Teamcenter, connectivity lists. But that process is following a workflow that's created a task in my Teamcenter inbox, and now I've generated that or published that design. I want Pete MCAD to be the reviewer, to actually push that design from a review mode into a release mode. Now Pete MCAD logs into Teamcenter, so this is who I am now. I can look at my inbox, and I can see that the electrical engineer, Nuri, let's call him, has created a set of documents for sign off, and so I can view those documents. I don't need to have Capital installed. I can view those documents and push that design through the release process. That now gets updated in Capital. We now know that design in Capital is released, and therefore as a released document, it's read-only. It can't be modified any further by anyone else in the organization. So the whole workflow is something that's orchestrated, and all the review processes can all be controlled by the PLM tool. So ultimately, as we've said in all these other examples, that is providing a fully integrated ecosystem where Teamcenter is a single source of truth. It's controlling it's the master of all the data, the mechanical, the electrical, the software, all the data used for the product design. It's all managed and orchestrated, and all the changes orchestrated by Teamcenter. So I think we're doing okay for time. We've covered what is the Siemens Accelerator, the Capital flow, and if we just go through and summarize, if we look at Capital Logic Designer, as Brian described, it's incredibly flexible and intuitive to use. This is the authoring tool for the connectivity, absolutely taking advantage of automation. So whether it's the assets that we have in our component library, or whether it's the ICDs that's describing how to connect signals to cavities of the connectors and the components, that's really the authoring tool for the connectivity. But once upon a time, that was probably all I needed, and then I could create harnesses. But as the electrical systems are becoming more and more complex, understanding how they fit together in the platform is becoming the next challenge. And so, sorry, I missed a step there. The topology allows me to view the overall platform and understand how all those different wiring harnesses are coming together to carry those different wires, ensuring that we're keeping our EWIS separation applied. So where we have electrical wire systems that should be separated by EMC category, we can actually visualize all of that in the topology design, in the Capital Wiring integrated design. But it's also allowing me to optimize the wiring. So where I'm giving a choice of different paths to take, I can choose which path to take. I can look at the pros and cons of all these different scenarios. I can also create alternative scenarios and do what if scenarios. What if we move these LIUs from this end of the aircraft to that end of the aircraft? What's the potential impact on weight and cost all of that can be evaluated with this topology architectural view of the wiring systems. By integrating with MCAD, with the 3D data, we're removing silos. We're breaking down silos. We're allowing the electrical engineer to work in co-design with the mechanical engineer. So it's not an afterthought to fit wires into a platform. We can actually work very early, and especially with NX, we can send logical data between NX and 3D, and actually use that as part of a very early space reservation flow. So really breaking down the silos, left shifting the process, and allowing for a much tighter integration, team harmony, when both teams can work together. Now, of course, taking that 3D geometry and generating all the documentation that's needed to manufacture the harness. It's a huge amount of automation here. It's accurate library-driven data. Those terminals are added into those cavities based on the rule selection, based on the wiring data that we had in the schematic. So everything in terms of bills of materials is driven by correct by construction information. And again, all of that's orchestrated by a PLM tool that can manage the workflow across all these different design domains, providing essentially the full digital continuity from on the electrical side, from the schematic all the way through to the manufacturing of the documentation, through MCAD. That's what Teamcenter is doing, and that's what the Siemens Accelerator. So if we go back to that 1990s video, and we're looking at the guy with the little lollipop, and he's there, and everyone's working together, and you got all these people waving their arms to say that their jobs are done. That process now, if we connect it, if we digitalize it, these are all YouTube videos. So now with the smartness that goes on, the whole process can be done 4 seconds quicker. So 1.8 seconds altogether. That's because they've connected all the tools and all the steps in the process. Right. If we look at some successes, so we have I look after mainly aerospace and defense customers across Europe and complex machinery customers. So, Korean aerospace industries, 20% reduction in the design time to create those electrical systems compared to the previous norms. They have a huge amount of automation that they've benefited from, and the data that they're creating is correct right first time. So that's a huge advantage to the organization. This is a small company in Denmark, Terma. They used what was Visis, and now it's Capital Essentials. And they noticed an elimination of a lot of the manual processes and checking that they used to have to do. So they had a lot of checks in the previous process because they had a disconnected wiring tool, a disconnected harness diagram tool, not connected at all with 3D. There were lots of steps where they had to recheck the data and lots of design reviews. But now they've digitalized that process between the connectivity authoring, the harness design, and the 3D. There's no need to check. There's no need to have as many manual checks in their process, and that's been a huge advantage to the organization. Over to Brian.
Excellent, thanks, Thierry. No, you got me. Thank you again for that presentation. That was good. It was really good insight into what the offering is from Siemens, this interactive flow, and hopefully it's been of benefit to ones that have attended today. And we're just going to pop up a poll very briefly on your screens. And what we would like to know at IC Blue is, would you like to get a hands-on workshop? Would you like to be involved? And if so, could you give us your preference on dates? Whether you would like to be involved and attend, or whether April would be of use, or maybe even in May. So we're just going to get some feedback from you, and then we'll plan accordingly. But thanks for submitting. I see all the votes coming in. That's great. So I believe it's something something that's been done in other countries, getting customers on site, getting interested parties on site. Having that discussion face to face sometimes even opens up more dialogue, and we can show you the tools in real time, which is good. So we've got a few more coming in. Yeah, thanks for that response. We're nearly at 80% of people who have voted, so thanks for that. That's really good. Okay. Excellent. Thank you again for that. So we're going to maybe just spend a minute or two. We've just got a few questions. It looks like it's a handful of questions that have come in during the past hour. So maybe we can just review a couple of these. Mike Hodgson has asked, is it possible to get a list of the components included in the component library manager? And do these include the NX 3D geometry with accurate mass data? So is it possible to get a list of the components? So there is an embedded library portal that the tool connects to, and it does provide free access to thousands of ready to import really symbols and components and parts from quite a lot of prominent vendors. Don't have a list, but we can check to see is there a list of what is available. And in this case, that particular one wouldn't include the 3D geometry, because Capital would not support the 3D geometry as such. That will be handled within the mechanical tool. But I believe the source is 3D Find It. Yuri, do you have a point on that?
Yeah, that's right. So thanks for the question. Capital comes with pretty much a starter library. It's got a lot of generic parts, but it's not too many. We do, as Brian says, we've got access to a 3D part Find It portal, which is Cadinus. There you can download parts, including a lot of the metadata to drive the parts, what terminals fits the connectors, etc. And for a lot of those components, there's also the 3D model. So from NX, you can download the 3D representation of those connectors, and then from Capital, you can download the Capital representation, so the form board, face view, side view, whatever it was, as well as all the library data to manage all the terminals and wires and the housing parts as we describe it. So hopefully, if you come get a hands-on, you can see what we provide, and maybe you can connect to Cadinus and download whatever parts you're looking for.
Very good, thank you. So we have Soren Dienpan thank you for your question. Would it be possible to export data between Creo 3D model and Capital Harness? So
I'll answer that. Yes, you can. Yep. So many of our customers, especially our heavy equipment customers, it seems, have Creo for their 3D, and so we have the same flow where we can send connectivity data to Creo. We can also bring the topology architecture into our topology tools and into our harness engineering tools. So we do have a Creo integration. There's two variants of Creo. There's a Creo Direct, and there's Creo Elements. I can't remember which one we support, but we only do support one of them. I think we support the one that was originally PTC, not the one that was Code Create. But we can confirm that to you in a reply email, which versions of Creo we're supporting. The one thing that we don't do with Creo, we do it with some of the Dassault products, and obviously with NX, we don't have the cross highlighting, so the ability to highlight in MCAD and to see the selected object, the equivalent object in Capital highlighted. There is no cross highlighting between the Creo platform and Capital, but the workflow is the same.
Excellent. Thanks for that. Thank you for your question as well. And we have Paul van Winderden. You've asked the question, can you use Windchill instead of Teamcenter?
I'll answer that one as well. Yes, we can. I mean, obviously, it's not something controlled by us. When we've developed Teamcenter and the Capital integration to be very, very closely coupled, but we do have a Windchill integration. It's not developed by Siemens. It's developed by one of our partners, XPLM. And if you go to XPLM's website, we can give you the details. You can see videos of Capital working with Windchill for managing of library parts as one use case, managing bills and materials, managing workflow, all through Windchill. So yes.
Excellent, very good. We have a question from Matt Roberts. Thanks, Matt, for your question. How would Siemens define the difference between a wiring diagram and a schematic? And in what phase in the design process would you expect to see each? So extracting the wiring diagram, I guess, from the schematic.
Yeah, do you want me to answer that?
Yeah, please.
Yeah, I mean, I would consider the schematic something quite logical. So, device A is connected to device B and connected to device C. It's really a logical abstraction. So you can use capital logic to do that, and that's what we had in our nets-based schematic. That was in the video. Of course, there's an advantage to creating a logical design. It's much more, as a system engineer, I can validate that logically this is correct. It's all functionally correct. But implementation, depending on the variant of the physical platform, the implementation could be very different. And so the wiring design is the implementation. And so that's when you decide A connects to B through these inlines, or through these connector pairs. That's the implementation. So the wiring design is definitely something that we have in Capital. And remember, I talked about 4 different flows with Capital. There's the interactive flow, which wiring design, harness design. Then we had the topology flow, and then we had the 2 generative flows. So those generative flows are able to take those schematic data, that logical data, and based on an architecture, it will synthesize the wiring. And so it synthesizes the physical implementation based on rules. And the rules can dictate where splices should be placed and to minimize overall wire length. And that's an implementation. So capital logic is used to either manually create both logical data and physical wiring data, or you can use a generative tool to try and automate that physical variant. Happy to discuss that in the workshop if you want to come and see that at first hand, where we explain both live.
Yeah, excellent. Thanks, Jerry. Appreciate that. I guess that comes to the end of our questions that we'll answer here online today, but we certainly follow up with any others that we've not addressed in this meeting. Just want to thank everybody, especially Yuri, for attending today, for giving us of your time and explaining the real advantages of the Siemens Capital portfolio. And I really do appreciate the way you're giving some insights into that, and hopefully it's been beneficial to the ones attending today. We really appreciate taking your time as well to be with us, and we hope to replicate this in different forms and different topics in the future. Please, as always, contact me. My email address is there on screen if you want to provide any feedback, or if you'd like to see anything in particular in the future, or of course if you'd like to request a copy of the slide deck for today. So with that in mind, I'll leave everybody to their afternoons. We thank you again for attending, and have a good evening.
Yeah, thank you, and look forward to seeing you guys in future. I assume somebody will now stop the broadcast. Yeah, have we stopped the broadcast?